Hello class, and welcome to Unit 4, Video 3. Today we're going to go ahead and look at factoring. The learning target for today is that you will be able to factor quadratic expressions. Factoring is a concept that comes up a lot in Algebra 2 and any math class you take after this. So if you have any questions, please be sure to let me know so that I can clear up any confusion you may have. Okay, so what is factoring? Factoring is simply the opposite of FOILing. Okay, and the opposite of distributing. So if you remember FOIL, okay, if we had x plus 2, x minus 3, if you were to FOIL this, you do your first two, so we have x squared, and your outer two, so 3 times, or x times negative 3, so negative 3x, and your inner two for the I, so it's 2 times x, so plus 2x, and then your last two, 2 times 3, negative 3, so negative 6. You would be left with x squared, if I combine these two, minus x minus 6. Okay, so this was from here to here, you use FOILing. Now we're going to do the opposite. So this was FOIL. Now we're going to factor. Now you're going to be given something like this, and you're going to go backwards. Okay, and this is factoring. So factoring undoes FOILing. Okay, so there's different ways of factoring. The first one is a GCF. When you talk about a GCF, you're going to factor out or divide by the greatest common factor. Okay, so GCF stands for greatest common factor. So if you notice that all of the numbers are divisible by 2, you're going to divide it by 2. Okay, so here's just a really quick example. If I have 4x plus 6, I notice they're both divisible by 2, so I'm going to put a 2 out in front, and I would have 2x plus 3. And if I rethink, if I were to distribute, I would get back to this. So here would be my factored GCF form. General trinomials in the form x squared plus bx plus c. Okay, this is when there's a 1 in front. In order to factor this, you're going to want to think what multiplies to that c value, but would add to b. Okay. And the form of this is going to be x plus some number times x plus some number. And we don't know what those numbers are, but that's what the factor of x squared plus bx plus c. When you get to a general trinomial of the form ax squared plus bx plus c, the difference is there's a number in front of that x squared. Becomes a little bit trickier problem. So when a is equal to a number greater than 1, the factor is going, when you factor, it's going to look like some number times x plus some other number, and then there's going to be a number in front of x again. Okay, so that's what's going to look like there. Then grouping. This is something that we're going to use when there's typically 4 terms, but the way you do grouping is you group the first 2 terms. And the last 2 terms. And take out the GCF. So we'll look at this more in detail, but that's what that would look like. In a way, typically you'd use grouping on when there's 4 terms. Okay, so just so you understand what 4 terms is, one example would be x squared plus 5x plus 3x plus 6. Okay, there's 1, 2, 3, 4 terms, and you'd look at the first 2, and then you look at the second 2. And we'll look at grouping more in the near distant future. Okay, so these are different types of factoring. We are going to talk about the first 3 today. Okay, so GCF factoring. So what you want to do is pull out the GCF from the factors and write it outside the remaining factors. So example 1. I would look at this and I would say to myself, what number is 12 and 36 both divisible by? It's both divisible by 12. So my GCF is equal to 12. there's an x here and there's no x here. So they don't both have it, so I cannot take it out. So my GCF is 12. I write it in front. And then I would say to myself, what is 12x divided by 12? Well, that's 1x. Minus, what's 36 divided by 12? 3. The other way you could think about it is 12 times what gives you 12x? Well, 12 times x gives you 12x. And 12 times 3 gives you 36. So the only thing that I would do is maybe rewrite this because we don't typically write that 1 in front of x. Okay, so we have 12 parentheses x minus 3. That is my GCF. Okay, looking at number 2. My GCF of this one, I look at my numbers. I have 8 and 16. They are both divisible by 8. Okay, and this one has an x squared and this has an x to the first. You can always take out the lowest. So if they each have an x, it's always the lowest exponent. So I can take out an 8x. So I write my GCF in front, and I would say to myself, 8 times what gives you 8? Well, 1. Then x times what gives you x squared? X. X times x, x squared. Plus 8 times what gives you 16? 2. And if I have x, I'm already good. So this one would be 8x and then x plus 2. And if I were to redistribute and think about it, would I get back to my original? Yes. Moving on to example 3 and 4. I have the numbers 39 and I have the number 13. Since there's a 13 there, I'm going to say, well, is 39 divisible by 13? And if you try it on your calculator, you will see that it is. So my GCF is 13. Then you can always take out the lowest exponent. So I can take out an x. Okay. So my GCF is 13x. I write that in front. 39 divided by 13 is 3. So there's 3. X times what gives you x squared? X. And 13x. 13x times what gives you 13x? Well, 1. Don't forget that 1. It's holding the place, so you don't forget that that piece is there. Okay, there's my answer for 3. 4, a little bit trickier, but I look at it. I have 5, 20, and 40. So they're all divisible by 5. So my GCF is 5. And then I would take out the lowest exponent. So here's 7, 3, and 2. So I can take out an x squared. So GCF is written in front. So I have 5x squared, parentheses. 5 times 1, so this is just going to be 1. And then x squared times what gives you x to the 7th? X to the 5th. Remember, when you multiply, you add exponents. So x squared times x to the 5th, 2 plus 5 is 7. Minus 5 times 4 is 20. And I would just have an x because x squared times x to the first would give me x to the third. Plus 5 times 8 gives me 40. And I don't need to add any on because I have x squared times that would give me x squared. So this would be my final answer here. So that is my GCF factoring. Okay. The next thing we're going to do is we are going to do general trinomials. So we're looking at when my number in front is 1. Okay, so find two numbers that give you a product of C and a sum of B. So remember, product is when it multiplies. So we got to multiply to this C value, and you have to sum, add to the B value. Okay, so let's go ahead and just look at our examples. We're going to go ahead and use a box method on this one to start out, and then we'll go to just guess and check. So my box method, just so you guys understand, you always put your A term here and your C term here. So right away I can go ahead and set up my box for this one. My A term is x squared, and my C term is 8. Okay. Then to figure out what goes in these other two boxes, I look at 1 times 8, which is 8. So in this case, I would have 1 times 8, which is 8. And then I'm going to go ahead. I would say what multiplies to 8, but would add to 6x. So I would think of my factors of 8. I have 1 times 8, and I have 2 times 4. Well, any of those add to 6x. Well, 1 times 8 won't work. But if I have 2x and 4x, those would add to 6x. So those two go in here. Then I would go ahead, and I'm going to do a little GCF work. So I would say, looking up and down, what can I factor? What's my GCF here? I can take out an x. Looking here, I can factor out a 2. If I go this direction, left to right, I can take out a x. And if I look this direction, I can take out a 4. So this is my answers, what's on the top and on the side. So this one factors to x plus 2, x plus 4. Okay, so another way to check is, do they multiply? Does these two values multiply to my c? Yes, 2 times 4 is 8. If I add them, I will get 6. All right. Now let's go ahead and do a little bit of just guess and check. We'll come back to this box method when the number in front is bigger than 1. This will really help organize our thoughts. Okay, so if we can, let's do guess and check, or you can do that box method. So in this case, we're saying what multiplies to 12 but adds to 13. So 12. If you're not sure, just start listing out your multiples. 1 times 12, 2 times 6, 3 times 4. Okay, well, this one might work. That will not, because 2 plus, that's only get you to 8, and this will get you to 7. So I'm going to have 1 and 12. I need to multiply to a positive 12 and add to 13, so both positive. There is my answer. Now I look at this next one, and I need to multiply to 4. So I pick my factors of 4. I have 1 times 4 and 2 times 2. Okay, I need to multiply to a negative 4, so there's going to have to be, one of these will have to be negative, and I want to add to 3. Well, this one is out. If I want to add to 3, negative 1 plus 4 adds to 3. Negative 1 times 4 is negative 4. So minus 1 plus 4. That would be my answer for 7. Okay, so that is when your when your term in front is a 1 for the x squared term. The next type of factoring we're going to look at is a difference of two squares. This is a sum and difference pattern. You are going to want to know this one. I will not tell you what it is again, or I will tell you what it is again, but I want you to have it down. If you're asking on a quiz, I'm not going to remind you what it is. You need to know it. So it's a difference of two squares. Okay, so if I have a number squared and another number squared, and difference means subtraction, and they're being subtracted, the way it's going to factor is you can take the square root of x right in the front, the square root of y right in the back, and then you always have a negative and a positive. Okay, so let's look at the examples we have here. I have x squared minus 4. I know that the square root of x squared is x. And I have 4. I would say, what's the square root of 4? That's equal to 2. So I would have 2, and since it's sum and difference, I would add 1 and subtract. And there is my answer. The reason this is my answer is you can think about what I have here, my original problem. I can rewrite it as x squared plus 0x minus 4. So you can go back to the type of problem we were doing before. You would say, what multiplies to a negative 4 but adds to 0? Well, my factors of 4 are 1 times 4 and 2 times 2. Well, I need to add to 0, so this one's out. If I have 2 and 2, to add to 0, one would have to be positive, one would have to be negative. So that's why this difference of perfect squares works out. Okay, moving on to my next one. I know the square root of 64 is equal to 8. So I have x plus 8 and x minus 8. That is my answer for number 9. So this is why it's really nice for you to notice that you have a difference of two squares, because it'll make the process go quicker. And our last one, we have x squared minus 25, so square root of 25 is equal to 5, so I have x plus 5, x minus 5. So try and be aware of this type of factoring because it will help you out greatly. Okay, now we're going to go ahead and look at when the a in front is bigger than 1. Okay, so looking here, my a is 2. My a is 2. So what I need to do is go ahead and I take, like we did before, we take your a times your c term. So we have our a times our c term. So in this case, it's 2 times 5, which gives you 10. Okay, so I have my 10, and I say what multiplies to 10 but adds to our b term, has to add to that 11. So I would list out my factors of 10 if you didn't see it right away. 1 times 10, 2 times 5, those are all my factors. Okay, I need to add to 11, so that takes out 2 and 5. 1 plus 10 is 11. Okay, so this is where I set up my box. Remember, my x squared term goes here, so I have 2x squared, and my c term goes here, which is 5. Well, 1 and 10, okay, those are my b terms, so they go here, and they're going to be 1x and 10x. So x and 10x. Now I do factor out my GCF. Okay, I look here. What can I factor out of here, my GCF? Well, they're both divisible by 2 and x. Here, I have 1 and 5. The only thing they're both divisible by is 1. So I write 1. Looking up and down now. Okay, what are they both divisible by? They both can have an x factored out. And here, they can both factor out a 5. And like before, our answers are right here. The way they are factored are 2x plus 1 and x plus 5. There is my answer, factored using our box method. Okay, let's go ahead and do number 12. Okay, first step, try and think in your head, what's the first step? What was the first thing that we do? We take our a times our c. So we take 3 times -7, which gives us -21. And then I think to myself, what multiplies to -21 but adds to -4? Okay, well, we know 1 times 21, and there's no 2 times, but it's 3 times 7. Those are all my multiples of 21. So I need to multiply to 21 but add to -4. This answer is out, can't happen. 3 and 7, if I have a -7, 3 minus 7 will give me -4. So I have 3x and -7x. And if I check, do they multiply to a -21? Yes, they do. So I set up my box. So remember, I have my ax term goes here, so it's 3x squared, and my c term goes here, -7. And then I write in my factors. So I have 3x and -7x. And then I go ahead and do the GCF. So if I look from left to right on this one, what can I take out of them both? Just an x. If I look from here to here, what can I take out of here? Nothing, just 1. Okay. Up and down, they both can take out a 3 and an x. And here I can take out a -7. Okay, so my answers, once again, are on the side here. So it's x plus 1, and in this case it's 3x minus 7. And there is my answer factored. Okay. Now we're going to go ahead and look at some mixed practice, because I'm not always going to tell you what kind it is. Okay, so the first thing I notice about 13 is it's just an x squared term. So I go back to my way of thinking, what multiplies to -36 but adds to 5. Okay, well, what multiplies to 36 but adds to 5? If you're not sure, like I said before, list out all your factors. Okay, so any of these starting to ring a bell? Well, 4 times 9 would work. Okay, well, I need to multiply to a -36, so that means one of them needs to be negative, and I need to add to 5. So that means a positive 5, so my 4 is negative and my 9 is positive. So there would be my answer for that one. I go ahead and I look at 14. I notice my number in front is a 2, but then I also notice it's a 16 and a 30. And I notice they're all divisible by 2, so I'm going to take out my GCF first. So my GCF for this one is 2. So I have 2x squared plus 8x plus 15. Now, I see this part right here is the same type of problem as number 13. So what multiplies to 15 but adds to 8? So what multiplies 15 but adds to 8? 3 times 5 is 15, and they add to 8. So I keep that 2 out in front, and this is my entire answer for number 14. Okay. Looking at number 15, I notice there's a 3 out in front. The first thing I want to check is, can I divide them all by 3? Is 12 and 15 divisible by 3? Yes. So my GCF for this one is 3. So I'm going to write that out in front like I did before. So I have x squared plus 4x plus 5. And now I would say, can I multiply to 5 but add to 4? Okay, my multiples of 5 are 1 times 5. Okay, so if I have a 1 and a 5, okay, can I add to 4? Well, I need to multiply to a positive 5, so that means they both have to be positive or they both have to be negative, which gives you 6 or negative 6. So can this one ever work? No, this one will not work. So this piece up here is actually your final answer. There will be times where you cannot factor it further. Okay. 16 looks a little bit different. Okay, it has an x squared here and a y squared in the back, and there's an xy in the middle. It's the same type of problem as this. The only difference is, since there's an x squared in the front and an x squared in the back, you're going to have x in the front of your parentheses and y in the back of your parentheses. Otherwise, you think about it the same way. What multiplies to 18 but adds to 9? Well, my multiples are 18. 1 times 18, 2 times 9, 3 times 6. 3 times 6 would work. So I would have 3 and 6. Together they add to 9, and they're both positive. So my answer for this one would be x plus 3y and x plus 6y. Okay, so don't let this y squared trick you. You just have to have a y at the end. And if you're not sure, you could go ahead and FOIL it and make sure you get the same answer you had before to make sure it works. All right, we have one. All right, so this is our last problem. The area of the rectangle is 8x squared plus 10x minus 3. So it says find the dimensions of the rectangle. Our hint here is that the area of a rectangle is length times width. Factor to get the length and width that was multiplied. So our area right now is 8x squared plus 10x minus 3. So we need to factor this. That will tell us what the length and what the width are. I noticed this one to factor. I cannot divide all of them by 8. Okay, so I'm going to have to do my box method. So what we need to do is I need to take 8 times negative 3, which gives me negative 24. Then I say what multiplies to negative 24 but adds to 10. If I start breaking this down, I would see that 2 and times 12 will give me 24, and I want to add to 10, so if I make a negative 2x and a 12x, that will add to a 10x, and if I multiply them, I get a negative 24. So box method, I'm going to put 8x squared here and my c term here, which is negative 3. Then I put my negative 2x and my 12x. So what I need to do is factor. Okay, so here I'm going to factor out my GCF. They're both divisible by 2 and x. Here they're both divisible by 3. If I look this way, they're both divisible by 4x. And here they're both divisible by negative 1. So my factored form for this one is 2x plus 3 and 4x minus 1. So that means my dimensions, we're not sure which one is the length and which one's the width, but my dimensions are 4x minus 1 and 2x plus 3. That would be my answer for that last problem. Okay, that's going to be it for our video for today. If you have any questions, please be sure to write them down. Otherwise, I will talk to you later. Have a great day.